Hello, astronomy. So today we are learning about stellar graveyards, or what stars leave behind when they die. So stars live for a very long time, and we're going to talk about, well, what happens when they die. I've posted this before in for previous astronomy days, but I'm showing you guys right now because in order to understand why stars die or why they leave behind what they do, let's just talk about a little bit about their life cycles. And at the very end of this, we'll talk about how stars are reborn. So whenever you see that word stellar, that's just an adjective for star. So stellar light is just light that comes from a star. Stellar graveyard is a graveyard for a star. So what are stars made of? So stars are made of a plasma, which is a gas heated to a temperature so high that the individual atoms lose their electrons. And that plasma makes nuclear fusion possible. In order to get nuclear fusion, you need to start with plasma. So inside of our sun's core, our sun fuses deuterium and tritium together to make helium and a whole lot of energy. So one thing to know about stars, that nuclear fusion reaction produces, like I said, a lot of energy. So much energy that it counteracts the force of gravity. So stars are really big. And since they're not made of solid material or even liquid material, gravity could compress them easily if it were not for the fact that there is a lot of outward pressure from the core of the star. So that outward pressure from the core of the star comes from that nuclear fusion reaction. So all those tiny little atoms that are being fused together, one by one, all together are producing this thing called radiation pressure or fusion pressure. And in the meantime, gravity is trying to pull the star inward. So the force of the star pushing out and versus the force of the gravity pulling in kind of gives the star the shape that it has. If it loses that force of nuclear fusion, the star would collapse. If it loses the force of gravity, in other words, if it becomes too big for gravity to hold together, it would just kind of poof away. Not really explode, but it would lose its outer layers. And that's actually two ways that stars can die. So let's look at small star fusion and death. So our sun is relatively small star. It's not the smallest star in the galaxies. In fact, there are many more smaller stars than the sun. It's kind of a medium star. Medium small star. So small stars begin by fusing hydrogen to helium. When that hydrogen supply runs out, the star might have enough energy to fuse helium into carbon or oxygen. Eventually, even that helium supply will run out as well. So when that helium supply is run out, the star doesn't really have enough energy to fuse the oxygen or carbon together. So it will produce what's called a planetary nebula. Now, planetary nebula is called a planetary nebula not because that's where planets come from, but planetary nebula used to astronomers used to look up in the sky and see these things and thought they were looking at planets. And when we got better telescopes, we found out, oh, these aren't planets, these are nebula. That kind of happens a lot in astronomy. We kind of mistake things for other things. Anyway. So planetary nebula have nothing to do with planets. They're just called that because we kind of thought they looked like planets. So the outer layers of the star will become this planetary nebula because when the helium is gone, basically the core will tighten. And when that core tightens, it sends out a huge burst of energy, which blows away the outer layers of the star. So now that the outer layers are so big, gravity can no longer hold it together as a star because there's too much radiation pressure or not enough gravity, however you want to look at it. The core of the star will remain intact. It will remain intact as a white dwarf, which is a very dense, very bright white star. It's also very small, about the size of the Earth. So that's small for a star. So that's how small stars live and die. Let's look at giant stars. So giant stars, when I say giant stars, I mean stars with twice the mass or more of our sun. So giant stars, they go through similar evolution of fusing elements. They fuse hydrogen into helium. Eventually, the hydrogen will run out. They'll fuse helium into carbon and oxygen. Eventually, the helium will run out. And this is where giant stars are different from stars like our sun, because the sun doesn't have enough energy to fuse things heavier than helium, but giant stars have plenty of mass and thus plenty of gravitational energy to smash together heavier elements. So once the helium runs out in a giant star, it keeps going. Its core becomes a lot more complicated because it has layers and layers of nuclear fusion. And this is kind of a diagram of what that might look like. It's kind of blown out of proportion, but each layer of the core fuses a different type of element. Then the most outer layer would fuse hydrogen into helium. Next would be form helium into nitrogen. Next layer is helium into carbon, so on and so forth, until it fuses silicon into sulfur, then nickel into iron. And the thing about iron is that all of these nuclear reactions, when you fuse hydrogen into helium, you make a lot of energy. When you fuse helium into nitrogen, you make a lot of energy, but not as much as the first one. When I fuse oxygen into carbon, I make a lot of energy, but not quite as much as the last one. When I fuse iron, when I make iron in a star, I make some energy, but not very much. When a star tries to fuse iron together, it actually takes energy to fuse iron. So it does take energy to fuse hydrogen into helium, but you get a net gain from that reaction. When you try to fuse two iron atoms together, that's a net loss. So now the star starts losing energy. Up until now, the core has been producing a lot of energy, but now it's taking energy to try to fuse all these heavy elements together. And if you can see at the bottom here, only stars of a 10 plus solar mass, so only stars that have 10 times the mass of our sun, can actually produce iron. But if a star actually does produce iron, that's kind of like putting a drop of poison in the middle of a star, because once a star produces iron, it's quickly on its way to death. Some estimates say that once a star produces iron, it has less than a minute to live. So a star that is 10 times the size of our sun will collapse in really less than a minute once it produces iron, which is pretty wild to think about. And there's some videos I encourage you to watch on today's agenda, because that is a huge explosion. What actually happens is that once the core can no longer produce energy, gravity takes over. Remember that balancing I actually told you about. Without that outward force of fusion pushing out, gravity takes over and crunches the star down. And so all the energy is trying to go toward the center of the star, and it bounces off the iron core, creating a huge explosion called a supernova. Supernova are some of the brightest and most energetic events that we know about in the universe. Whenever we see a supernova in another galaxy, it outshines that other galaxy. So they're huge explosions. Just like a small star, though, the core of the star is still left intact. So depending on how much mass that star and the core had, it could either leave behind a neutron star or a black hole. A neutron star is a super dense star. It's about the size of a metropolitan city, but it could have twice the mass of our sun. So it's a very dense star. And any denser than a neutron star, and we basically reach a limit to where nothing can escape the gravity of this object, not even light can escape, which is why we call it a black hole. Black holes are just objects that are so dense that not even light can escape from its gravitational grasp. And since light can escape, it doesn't really shine at all, because if no matter how warm it is, no matter how much light it gave off, the gravity would just pull that light right back in. And you can actually see the one and only photo that we have taken of a black hole so far right there. Everything else on this page is an artist rendering. So whether it was a nova or a supernova, no matter what kind of star dies, it always leaves behind something called nebula. Remember the very first star I told you about, the low mass stars, sheds its outer layers, and those layers stay in space. They're still there. That plasma condenses into a gas and forms these huge gas clouds we call nebula. Even a supernova will leave behind a gas cloud. Remember, I said that all of that star's matter that's getting crunched in bounces off and leaves behind this huge gas cloud called a nebula. The cool thing about nebula is that just like stars, the force of gravity works on nebula as well. So it takes a long time, but eventually these gas clouds have the potential to collapse. And once the gas cloud collapses, it has a potential to form a new core or a new star for a new star to be born. So that is stellar life cycles, how stars die, how they're reborn. It really depends on what kind of star you start with. Hope that helped. I have some additional videos in the agenda for you guys to help you on the assignment today. If you have any questions, let me know, and I'll talk to you later.